More than 4 millennia ago, farmers in East Asia recorded a watering practice so effective that a single refill could sustain crops for an entire week, even through the harshest growing season. This approach appeared in some of the earliest agricultural writings ever preserved. It described a deceptively simple idea. Place an unglazed clay vessel beneath the soil and allow the earth itself to regulate when plants receive water. No engines, no schedules, no daily effort. Just baked clay and natural forces. What began as a local farming insight did not stay local for long. The idea traveled far beyond its place of origin. Engineers in Persia modified it for extreme aridity. Indigenous societies in the deserts of North America refined it into complex systems. Early settlers in drought-prone regions relied on it when other farms failed. Across cultures and continents, the same principle reappeared. Bury clay, add water, let the soil decide. Then, sometime in the middle of the 20th century, the method faded from view. As modern irrigation technologies entered agriculture, the buried vessel quietly vanished from manuals, extension programs, and classrooms. It was not abandoned because it stopped working. It disappeared because it did not fit the economics of the new era. A clay pot, once installed, demanded nothing more. Today, many people believe that efficient irrigation must involve plastic tubing, regulators, filters, timers, and ongoing upkeep. We are told that saving water requires sophistication and constant oversight. But consider an alternative. A system that costs less than a household plate, consumes no power, and becomes more effective the less you interfere with it. The oldest known written reference to this technique appears in an ancient Chinese farming guide compiled during the Han period. The instructions are unusually precise. They specify the number of planting pits per hectare. They define the size of each earthen vessel. They explain how deep it should be buried and how often it should be refilled. What they do not explain is the theory behind it. The authors never attempt to justify the method scientifically. They simply record that it works. Generations of farmers followed those steps without understanding the underlying mechanics. They did not need equations or models. They needed harvests. And the harvests came. Crops survived dry seasons. Labor demands dropped dramatically. Plant diseases associated with wet surfaces declined. The system proved itself year after year. This approach was not confined to East Asia. As trade routes expanded, the idea migrated west. In the Middle East, adaptations appeared in some of the driest landscapes on Earth. Archaeologists have uncovered buried irrigation vessels across ancient Mesopotamia, evidence that the same concept was independently valued wherever water scarcity threatened survival. Across the ocean, long before European contact, societies in what is now the American Southwest developed extensive buried pot networks. These systems supported agriculture in environments where rainfall was unreliable and surface irrigation was inefficient. When Europeans arrived centuries later, they encountered not primitive farms, but landscapes shaped by generations of refined water management. The underlying science is simple, though it appears almost magical at first glance. The key is soil moisture tension. Unglazed clay is not sealed. It contains countless microscopic pores. When water fills the vessel and dry soil surrounds it, a pressure imbalance forms. The soil pulls moisture through the clay wall. As the soil becomes wetter, that pull weakens. Water movement slows. Once the surrounding ground reaches adequate moisture, the flow effectively stops. If rain saturates the soil, the system shuts down entirely until dryness returns. This is not mechanical regulation, it is physical law. Because the release depends on soil conditions rather than human timing, the system continuously adjusts. Hot days, cool nights, Growing roots, shrinking roots, dry spells, rainstorms, all are accounted for automatically. Plants respond quickly. Roots sense the moisture gradient and grow toward the vessel. Over time, they wrap around the clay surface, forming dense networks that draw water precisely when needed. The plant is not a passive recipient. It is an active participant, exerting pressure and demand. No electronic irrigation system adapts this fluidly. Modern measurements confirm what ancient farmers observed intuitively. Studies comparing buried clay irrigation to surface watering show dramatic improvements in water efficiency. Delivering moisture underground eliminates evaporation. There is no runoff. Every drop either enters the soil profile or remains in the vessel until needed. Weeds also decline. Seeds near the surface depend on moisture at the soil-air boundary. When water never reaches that zone, weeds struggle to germinate. Crops benefit. Competition decreases. Labor required for weeding drops. By any practical measure, water conservation, labor reduction, plant health, yield stability, the buried vessel performs exceptionally well. So why was it abandoned? The answer lies not in agronomy, but in incentives. During the 20th century, irrigation technology shifted towards systems that could scale industrially. Plastic tubing with calibrated emitters was a breakthrough. It allowed precise delivery across vast monocultures. But it also introduced dependency. Tubes degrade, emitters clog, filters require replacement, timers fail. Expertise becomes necessary. This is not a flaw, it is a model. A buried clay pot offers no recurring revenue. Once purchased and installed, it does not demand upgrades, service contracts, or replacement parts. From a commercial perspective, it is a dead end. From a farmer's perspective, it is liberation. As agricultural institutions modernized, methods that aligned with industrial supply chains gained prominence. Techniques that could not be monetized repeatedly were sidelined. Buried vessel irrigation became a footnote, described as outdated rather than effective. This was not an organized effort to suppress knowledge. It was structural. Educational systems mirror the industries that support them. Technologies with ongoing costs naturally receive more attention than those that solve problems permanently. Recovering this approach requires no special access. The materials are ordinary. An unglazed clay pot, a way to seal the drainage hole, soil, water. The pot is buried so that its walls contact the surrounding earth. The rim remains slightly above the surface to prevent contamination. The opening is covered to reduce evaporation. Once filled, the system begins working immediately. Plants are placed around it, not on top of it. Roots explore. They find the moisture source. Within days, the relationship is established. A small vessel can irrigate a surprisingly large area. Larger ones extend that reach further. In peak summer heat, refilling may be needed weekly. In mild conditions, even less often. Overwatering cannot occur. The soil controls the exchange. The disappearance of this method was not the result of new evidence disproving it. It was the result of economic structures determining which solutions were emphasized and which were ignored. Large-scale agriculture still requires complex systems, but complexity is not inherently superior. For home gardens, small farms, and water-limited environments, simplicity often wins. The knowledge never vanished. It waited quietly in the soil, doing exactly what it had always done. What unsettles modern thinking about this method is not only that it works, but that it works without oversight. There is no programming, calibration, or daily adjustment. Once the vessel is buried and filled, it fades from attention. The system operates quietly beneath the surface, responding only to soil conditions and plant demand. This lack of visible control runs against how most people are taught to garden. Watering is usually an active task. Hoses dragged out, timers adjusted, sprinklers turned on and off. Buried clay irrigation removes the gardener from that loop almost entirely. The soil decides when water moves. The plant determines how much is taken. That reversal feels uncomfortable at first. Modern systems place humans in charge. This one asks for trust. Roots are not passive structures. They respond to pressure gradients and moisture differences. When water is available nearby, roots grow toward it. When moisture is sufficient, they stop drawing. The buried vessel simply creates a stable source that roots can access on demand. Nothing more is required. Over time, this arrangement changes the soil itself. Because water is released slowly and only when needed, the surrounding soil never experiences flooding or extreme drying. Air spaces remain intact, microorganisms flourish, fungal networks expand. Nutrients remain available instead of being washed away. Surface watering disrupts these relationships. Repeated wetting and drying at the top layer compacts soil, encourages crust formation, and pushes nutrients downward beyond the reach of roots. Buried delivery avoids those cycles. The most biologically active zone remains consistently habitable. Temperature stability is another benefit. Water stored underground does not heat rapidly in the sun or cool sharply at night. This moderates root zone temperatures and reduces plant stress. Less stress means steadier growth and more energy directed toward fruit and seed production rather than survival. These effects are subtle, but they accumulate over a season. Plants watered this way tend to grow more evenly. They are less prone to splitting, bitterness, or sudden dieback. Flavor and texture often improve, not because anything extra was added, but because stress was removed. Despite these advantages, the method remains largely absent from modern gardening guidance. Part of the reason is scale. Buried vessels are not designed for vast monocultures managed by machinery. They are suited to gardens, small plots, and diversified plantings where efficiency is measured in resilience rather than uniformity. Another reason is visibility. Modern irrigation is easy to see and demonstrate. Pipes, emitters, and timers look technical. Buried clay does not. Its effectiveness is hidden, revealed only through plant health over time. What cannot be seen is harder to promote. There is also a cultural bias toward complexity. Progress is often assumed to involve adding layers, more controls, more components, more data. This system does the opposite. It removes layers until only essentials remain: water, clay, soil, roots. That simplicity is often mistaken for primitiveness. In reality, it reflects a deep alignment with natural processes. The system works because each part behaves according to physical law. No single component is smart, yet the whole behaves intelligently. Using this method requires adjusting expectations. There is no immediate feedback. You do not watch water flow. You do not hear anything turn on. Confirmation arrives later, in the form of plants that remain hydrated even during heat waves. At first, many people check the vessel frequently, expecting the water level to drop quickly. Often, it does not. The soil draws moisture slowly. When rain comes, the vessel may not empty at all for days. This is not failure. It is the system responding correctly. Over time, trust builds. The gardener intervenes less. Watering becomes an occasional check rather than a daily chore. Anxiety fades. Attention shifts from equipment to observation. This shift may be the most profound outcome. Gardening becomes less about control and more about cooperation. Instead of forcing water into the system, one provides access and steps aside. The method also aligns naturally with modern concerns about sustainability. It conserves water, uses no energy, requires no manufactured replacement parts, and produces minimal waste. Yet it was not created to meet environmental goals. It emerged as a survival tool in water-limited landscapes. That origin matters. Technologies developed under survival pressure tend to be robust. They must function without support systems. They must tolerate neglect. They must continue working when conditions are unpredictable. Buried clay irrigation meets those requirements. As climates become less stable and water availability more uncertain, such qualities regain importance. Systems dependent on constant maintenance become fragile. Systems dependent on physics remain dependable. This does not mean rejecting modern technology. It means choosing appropriate complexity. In many contexts, especially at human scale, simpler systems outperform elaborate ones because there are fewer points of failure. The buried clay vessel is not symbolic or nostalgic. It is not an aesthetic choice. It is a practical interface between water and roots that happens to be ancient. Its longevity is evidence of its effectiveness. Across thousands of years and multiple civilizations, the same idea reappeared wherever water scarcity threatened crops. That repetition is not coincidence. It is convergence. Water needs have not changed. Soil behavior has not changed. Plant physiology has not changed. The materials involved still behave the same way they always have. What has changed is perception. We are accustomed to solving problems by adding mechanisms. This method solves multiple problems by removing them. No evaporation, no runoff, no overwatering, no schedules, no constant attention. Everything unnecessary falls away. When water is placed where roots actually function, many secondary problems disappear on their own. Weeds decline, nutrients stay put, plants stabilize. The system does not demand belief. It only requires patience. Bury it. Fill it. Let time demonstrate the rest. If this perspective altered how you think about watering or garden technology, leave a comment sharing your experience or thoughts. Sometimes the most effective solutions are the ones we stop trying to improve. Thank you for watching this video. Click here to watch another video that might interest you.